Chapter 2, Exercise 24. Part A. Show that if script A is non-empty, then the power set of the intersection of script A is equal to the intersection of the power set of X such that X is in script A. And part B is show that the union of PX, power set of X such that X is in script A, is a subset of the power set of the union of script A. With the additional question, under what conditions does equality hold? This exercise is a bit longer than usual, I'd say. At least it took me longer. It had me thinking for quite a while, but it's mostly just, as usual, an application of the definitions that we've seen in this chapter. So let's start off the equality proof as we usually do. Let's suppose A is in the power set of the intersection of script A. Right, then by definition of being in the power set, A has to be a subset of the intersection of script A. So for all little a in big A, I'm going to call it, little a is in script A. So hold on, no, it's in the intersection of script A. And what little a being in the intersection of script A means, it means that, so for all X in script A, little a is in X. And putting this fact here is we say that for all a in little a and big A, little a has to be in X. So for all X in script A, this means that A, big A, is a subset of X. So for all X in script A is in the power set of X. And then what this means is that this has to be in one sec. So for all X in A is in the power set of X. So there's so many so's. Right. So A is in the intersection of PX such that X is in A. Is that right? If it's in the intersection, yeah, because it is big A is in every element that is contained within this set. So yes, it has to be in the intersection. And thus, power set of the intersection of script A is a subset of the intersection of PX such that X is in script A. Okay. And now we suppose that A is in the intersection of PX such that X is in script A. And then this is kind of just the same proof but backwards. Then for all little a and big A, little a hold on. No, sorry. This is not how it goes. So for all PX in the set PX such that X is in script A is in PX, which is the same. as saying that for all x in script A is a subset of x. Right. This means that for all x in script A, for all little a in big A is in x. So, for all little a in big A, little a is in the intersection of script A, meaning that A is a subset of the intersection of script A, which is the same as saying that A is in the power set of the intersection of script A. And thus, this set that we started with is a subset of the power set of the intersection of A. Now, is this the set we were looking for? Yes. Okay, fantastic. We conclude that the power set of the intersection of script A has to be equal to the intersection of Px such that x is in script A. Okay, so that's part one. Now part two is going to be show that this set is a subset of this set. So we kind of just flip over the intersections, turn them into unions. Now let's see. So, hold on. Union Px such that x. What is up with my handwriting today? PUA. Okay. Yeah. Sorry, I hope I'm not making this too motion sickness inducing. Right. So, let's see. Let's suppose, forgot the E. Suppose A is in the union of Px such that x is in script A. Then, by definition of the union, there exists some Px in the set Px such that x is in script A, such that A is in Px. So this is the same as saying that there exists some x in script A such that A is in x. Okay. So, no, such that A is a subset of x. There. Okay. Yeah, that's what looked funny to me. Okay. So, well, what happened? Oops. All right, my iPad just glitched out for a sec. So, what the hell? So, for all little a and big A, little a is in x, and this specific x. I need to find a new word. So just is so repetitive. I can't escape this word. Okay. Thus, there exists some x in script A such that uh, sorry. For all little a and big A, there exists some x such in script A such that little a is an x. Thus, for all little a and big A, little a is in the union of script A, because there is some element here such that A is in that element. Okay. And hence, A has to be a subset of the union of script A, meaning that A is in the power set of union of script A. We have we have arrived at the fact that the union of Px such that x is in script A is a subset of the power set of the union of script A. Alright, so we've done most of the work so far, and now all we have to do is answer this obnoxious question. I hate these sorts of questions. Let it be known to the whole world that I don't like these kinds of questions. But we have to find out under what conditions equality holds. The reason I don't like them is because they're much less straightforward than a proof. I mean, if proofs are hard in and of themselves, then just like coming up with some notion of what specific cases equality holds in, it's so annoying. But anywho, let's try to find some general pattern for when equality must hold. So I'm gonna just read. So when does equality hold? So this is the same as saying that union of Px such that x is in A is equal to the power set of the union of A, but by part B, or rather, yeah, let's just say part B, union of power set of x, which is x is in script A, is already a subset of the power set of the union of A. So the question reduces to when is it true that the power set of the union of script A is a subset of the union of Px such that x is in script A. Okay, I hope that's somewhat legible, but you get the idea. We just want to show some pattern for when inclusion in the other way works, or when it's true. Right, so let's suppose, and try to get rid of the so's. Let's suppose that A is in the power set of the union of A, then A has to be a subset of the union of A. Right. And actually, before we go there, let's try to work this backwards. So working backwards, we eventually want to find that A is going to be in the union of Px such that the x is in script A. And for this to be true, there must exist some Px in Px such that x is in script A, where A is in Px. Since we're working with a power set, we can further decompose this property and say that this is the same as saying that A is a subset of X for some X in script A. Right. So thus, for all little a in A is in X for some X in script A. So this is kind of what we want to arrive at, right? So in other words, what we're saying is that we want to find one particular X, a single X that contains all the elements of A. That is how we find inclusion the other way around. And the way you can think about this is A is a subset, or rather, okay, let's work this slower. So now if A is in the power set of the union of A, as we assumed it to be, then A is then A is a subset of the union of script A, right? So for all A, little a and big A, little a is going to be in the union of script A. Now what this means that for all little a in script A, in big A, there exists some X in script A oh, such that little a is an X. And at first glance, you might just say, well, that's your proof, right? Like, there you go. And like, what's the big deal? But you see, we're just saying that if you pick any little a from big A, then you can find some element X in script A such that little a, is an X. And that can be problematic since we're trying to find a specific X that contains all of the little a. Now, if you have a set where you have something like this, let's say that script A is going to be the set 1, 2, and 3, right? And let's say that big A is just equal to 1, 2, and 3. Why not? Then the union of script A is going to be 1, 2, 3. And A certainly is a subset of the union of A, but there is no X in script A such that 1 is an X, 2 is an X, and 3 is an X, which is what we were trying to find. So now, in contrast, if we were to have some set like, let's call it script B, which is something like 1, 2, 3, and then I don't know, like 1, 2, and that's about as many squiggly breaks I can draw. Why are all my numbers ugly? Okay, and let's just say that capital B is something like 1, 2, right? Then, or actually, let's just say it's 1, 2, 3. Then the union of B is going to be equal to uh, set 1, 2, 3. Why am I complicating this so much? Okay, yeah. So this is what the union of B is, and note that. Yeah, I'm gonna color code this. Okay, so let's call this one. Let's color it in a bit nicer. Let's call this one X1, and oops, this one is gonna be called X2. And note that for all little b, I'm gonna call them in big B, and the little b's are 1, 2, and 3. Oh wait, no. 1, 2, and 3. So this is B1, B2, B3. Whatever, I'll just do it B2, B3. For all little b in big B, there exists an X in B, sorry, in script B such that little b is an X. And then furthermore, there exists an X, and I'm going to call it X1 in script B such that for all little b in big B, little b is an X1. So this is the kind of set we're trying to find. And note that it's not enough that this property right here, or this kind of statement holds for this specific B, it has to hold for every possible B. So it has to hold for any subset of the union of script B, or as in our original example, any subset of the union of script A has to have, sorry, so what's the, why are these sets so complicated? Okay, yeah. So every A in the power set of the union of script A, meaning that every A that is a subset of the union of script A has to have an X, or there must exist an X that contains all the members of big A. I don't know why that's so hard to say, but in more mathematical notation, which is what I'm comfortable with. So For all A in the power set of the union of A, there exists some x in script A such that A is a subset of x. So if you can prove that, if your set has this condition,
And look at the
what the fuck? Okay. If your set satisfies this condition, then you have equality. Okay. I'm getting all tangled up. I'm getting all confused, honestly, trying to work out these examples, and this is why I hate this kind of question. But anywho, what I'm trying to get at is since you have this, since this needs to happen for every possible big A that is in the power set of the union of script A, then there must exist some x in script A that contains every element of the union of script A, because the union of script A is a subset of the union of script A. So there must exist some x in script A such that the union of script A is a subset of x. Is that right? It made sense a second ago. Yeah, right. Uh, I'm gonna leave it like that. In other words, there must exist some x in script A contains all the elements of the union of script A. There must be some, so there exists some x such that for all x in script A, x, alright, there must exist some, I'm going to call it x star, in script A such that for all x in script A, x is a subset of x star. Yeah, let's say that. That's true. All I'm saying is there has to be some like superset of all other sets. There must be some big set in script A where you can find every player that isn't um all the other elements, all the other sets contained in script A. That is so hard. Okay. Right, so I can say that, right? But let's somewhat prove it. I kind of have a proof, and feel free to correct me in the comments if this is wrong. But in general, the issue is if you don't have this X star that contains every element in script A, then you can always construct a subset that of the union of script A that has elements that don't all belong to the same X. Ah, this made so much more sense yesterday. Okay. Okay. So if no such X star exists, this is my proof, by the way. Uh, then I'm just copying it straight from my notebook, which is not the best source of information sometimes. There exists x1 and x2 in script A such that x1 is not a subset of x2 and x2 is not a subset of x1. Okay, right. Now suppose A is equal to the union of A, as I was arguing a little bit earlier. Then, or actually, I forgot to finish this one. Okay, all right. So what I'm saying in this line is that they have elements that are not contained in, that are exclusive to each one. Then there exists little x1 in big X1 such that little x1 is not in x2 and that's not the notation we use here. And there exists a little x2 in big X2 such that little x2 is not in big X1. Okay, now suppose A in the power set of the union of A is equal to the union of A. Or rather, let's just say A is equal to the union of A. Note that the union of script A is a subset of the union of script A, which implies that the union of script A is in the power set of the union of script A, in case that wasn't clear. Right. If A is in fact the union of script A, then since x1 is in A, little x1 is in the union of A, and since x2 is in script A, then a little x2 is in the union of script A. Right? So, what does this mean? Okay. So if there so if what? If A equal union of A is in the union of Px such that X is in script A, then as established earlier, A there exists some X such that uh, A is a subset of X. So, okay, there exists some X such that union of script A is a subset of X. So little x1 is an X and little x2 is also an X. Right? Okay, I should have made this more clear, but this is a proof by contradiction. Um, which is why I say that it's not good to copy from my notebook because I make these assumptions implicitly. So assume, my bad, assume by way of contradiction that no such x star exists, but uh, power set of the union of A is equal to the union of px such that x is in script A. Okay, yeah, this is where things start to make sense. Okay, then for all x1 in script A, there exists some x2 in script A such that x1 is not a subset of x2 and x2 is not a subset of x1. Okay, that's what I was trying to get at. Okay, so what I'm saying here is that for any pair of sets contained in script A, or rather, if you pick out any element of script A, any set X, call it X1, then you can always find an X2 in script A as well, such that they both have distinct elements. That's the argument I'm trying to make. And that's the argument I didn't understand until I started filming this video. Sometimes I film these videos like halfway through working out the solution in hopes that I'll figure it out like on the way. And sometimes it works. Sometimes I just embarrass myself so much that I re-roll the whole thing. But this time around, it kind of worked. Okay. All right. So here's a proof again. And let me just recap a little bit. So what's important to know for this part is that our number one condition is that, or the condition that we're looking for is that there exists some x in the some x in script A, such that big A is a subset of x, meaning that there exists some x in script A such that every little a in big A is in that x. And this is for every possible big A in the power set of the union of x. So any possible subset of the union of script A. Wait, I just said power set of union of x. Okay. So this has to hold for any big A that is in the power set of the union of script A, meaning that this has to hold for any possible subset of the union of script A, right? And what I'm just saying, and what I've been trying to say this whole time, is that the union of script A is a subset of the union of script A, right? So if you want to prove it in the most generality in this case, then you have to show it for the union of script A itself, right? So what I'm saying is that let's assume that there's no such x star, no such set x where you find that x is a subset. Sorry. Ah, this is not true. Okay. Oh my God, I've made so many mistakes this way in this video. All right. Recap part two. All right. So we want to. The condition that we found is that there exists. I'm going to write this in pink. Why not? So their condition for all A in the power set of the union of A, there exists some x in script A such that A is a subset of X. That's our condition. That's what I'm trying to say. This one, this right here. Right? Okay. Then this is just another way of rewriting this part specifically. Okay. Now my claim is that this means that there exists some X in script A that contains all the elements of the union of script A. And this is the same as saying, so these two are the same, that there exists some X star in script A such that for every X in script A, X is a subset of X star, meaning that there's some like superset of every other set. I mean, that's literally the same thing. But anywho, okay. And what I'm trying to show is that by contradiction, if no such X exists, then these sets cannot be equal. Okay, now let's assume that these two sets are equal, meaning that this condition holds, this condition holds, but this is not true, right? Then another way of saying that no such X star exists is that saying that if you pick any X, call it X1 in script A, then there must exist some X2 in script A as well, such that they are none of them is a subset of each other. That holds for any pair of elements, right? And what I'm saying here is that then there must exist some specific element in each one of them that isn't contained in the other set. This is little x1 and big X1. That's not in big X2. Little x2 and big X2. That is not in big X1. Okay. Now, what I'm saying here is that if this has to hold for every single A as assumed by our condition, then it must hold specifically for the union of script A, right? Now, since x1 is in script A, then little x1 is in the union of script A. And since x2 is in script A, then little x2 is in the union of script A, right? So now what I said is if these two sets are equal, then the union of A is in this set. Then, as we had established earlier, there exists some X such that A is a subset of X. So there exists some X such that union of A of script A is a subset of X. So what does this mean? So x1 hold on. What am I trying to say? Oh, I should establish something else before. Note that for all X in script A, X is a subset of the union of script A. Yes. So what I'm saying is if X is in script A, then for all little x in big X, there exists some X, the same X, in script A, such that little x is in big X, which is kind of obvious. But what this tells us is that little x is in the union of script A, which is the same as saying that big X is a subset of the union of script A. Right. So now coming back to my argument, as we established, there exists some x star such that A is a subset of x star. There exists some x star, I should have done this starting earlier, such that union of script A is a subset of x star. And now, since for all big X in script A, X is a subset of the union of script A, then by transitivity, of the subset relation, then X has to be a subset of X star for all X in script A. And this is where we find our contradiction. So, because we assumed that there is no such X star that contains all of these, right? Therefore, um, therefore this part is wrong. So let's spell it out more clearly. The contradiction is, we have A, that for all x1 in script A, um, wait, yes, there exists some x2 such that x1 is not a subset of x2, and x2 is not a subset of x1, right? So this is our initial assumption. And then B, we have that for all x in script A, there exists x star such that this might be wrong now that I look at it again. My brain is a little fried. Okay, but let's just keep going because this is how math works. And I might just upload this video anyways because, I mean, at least the first part was good, right? It was decent, and no one's going to watch this anyway. So, for all big X in script A, there exists some X star such that X is a subset of X star. Uh, is this right? I'm going insane. Am I capturing? So, for every set, maybe this is not what I wanted to say. Maybe this A part is not real. Maybe what I wanted to say is that it is not the case that there exists some X star such that for all x is a subset of x star, which should be equivalent to for all x star. It is not the case that for all x is a subset of x star, which is no, wait, then it should be. It do be 1 in the morning. My brain is not as good as it usually is. Okay. It is not the case there exists an x. Or maybe this is what I'm trying to say. I will do a recap once more. Maybe this is what I was trying to say. Yeah. Maybe this simplifies the proof quite a bit. Maybe it wasn't as complicated as I thought. Okay. Let's start over. But this does give us some information. I'll upload this one. And if you're watching this, just to show you that. And you've probably lived this yourself, but math is not a linear process. Or rather, it doesn't always go in a forward direction. Sometimes you have to step back and redo things. Okay, so let's assume by way of contradiction that no such x star exists, but the power set of the union of A is equal to the union of the power set of x such that x is in script A. Okay, then it is not the case that there exists some x star such that in script A such that for all x in script A, x is a subset of x star. Right? This is our initial assumption. And this is, you can rewrite this equivalently as for all x star in script A. It is not the case that for all x in script A, x is a subset of x star, which is equivalent to saying that for all x star in script A, there exists some x in script A, so it is not the case that x is a subset of x star. And then equivalently, for all x star in script A, there exists some x in script A, such that x is not a subset of x star. So these is just me playing around with the logic, but that's kind of beyond the point. Now, if power set of the union of A is equal to the union of the set Px such that x is in script A, then for all A in PUA, A is in U, Px such that x is in A. So, uh, as established earlier, there exists some x in script A such that A is a subset of x. And this holds for all A in power union of script A. Okay. Then what? All right. Okay. Then since UA is a subset of UA, UA is in PUA, so there must exist some x in script A such that union of script A is a subset of x, right? Note that the union of script A is for all x in script A, for all little x in big X, there exists some x in script A such that little x is in big X, and thus for all big X in script A, and thus little x is in the union of script A. Thus, for all big X in script A, big X is a subset of the union of script X. So, by transitivity of the subset relation, for all big X in script A, there exists some x star in script A such that x is a subset of union of script A is a subset of x star. So there exists some x star in script A for all x in script A such that x is a subset of x star, which directly contradicts our assumption. So we have this statement, and we also have this statement. So, what am I trying to say? So, not so if power set the union of A is equal to the union of Px such that x is in script A, then such an X star must exist. And maybe I didn't even actually need to do it by contradiction. Perhaps. Um, right. And then notably, this is actually a better condition than what I had before. Since for all x in script A, x is a subset of the union of script A, then x star is a subset of the union of script A. So a more succinct condition for when 𝒜 script A is equal to the union px such that x is in script A is that the union of script A is in A. Um, yeah, because this implies that the union of script A is equal to x star. If A is a subset of x star and x star is a subset already always of the union of script A, then they have to be equal. So if there exists such an x star, then it has to be equal to the union of script A. So um, the union of script A has to be in script A, which is interesting. It's something I didn't know before filming this video. Anywho, that is the when does equality hold portion. It was very poorly made compared to at least the first two parts and what I usually do in my videos. This has to be one of the more confusing questions I've come across. Um, again, I do despise the under what conditions does equality hold kind of questions. I think Enderton was foul for that one. Um, and I would say that I'm going to record this again later, but I also don't want to lie to you, and I kind of never want to see this question ever again in my life. So, with that said, I hope that this video was helpful, and I will see you in the next one. Bye bye.